Class 11th Chemistry. We were discussing Unit 7 Equilibrium, and in this video we are going to discuss about pH scale. A scale for measuring hydrogen ion concentration in solution is called pH. The P in pH stands for Potenz, in German meaning power, that is power of hydrogen. The pH of a solution is defined as the negative logarithm 2 base 10 of the activity of hydrogen ion. This activity of hydrogen ion is represented like this. In dilute solutions where concentration is less than 0.01 m, activity of hydrogen ion is equal in magnitude to molarity, represented by this one. It should be noted that activity has no units and is defined as concentration of hydrogen ion, that is molarity of hydrogen ion per mole per liter. So in this way activity has no unit. Mathematically we can write pH is equal to minus log of activity of hydrogen ion, or we can write minus log of concentration of hydrogen ion per mole per liter. Okay, in the simple way we can say pH is the negative logarithm of hydrogen ion concentration. Okay, thus in acidic solution of HCl and its concentration is 10 to the power minus 2 m. Again remember, when this is the concentration of HCl, so we can say when this one HCl is dissociate, it will give the one H plus ion. So concentration of H plus that is H plus ion is also 10 to the power minus 2 m. So this solution has pH is equal to 2. With this formula we can calculate this. pH is equal to minus log of hydrogen ion concentration, and this is equal to minus log of 10 to the power minus 2. And I think you are familiar with this, how to solve logarithm. Okay, this power minus 2 will come before it. Okay, so that's why this becomes plus 2 and log 10 is equal to 1, so we will get 2. In the same way, a basic solution of NaOH having hydroxyl ion concentration 10 to the power minus 4 m, then what will be the hydrogen ion concentration? This will be 10 to the power minus 10 m. I think you can also solve it. We have already discussed, that is concentration of product of the concentration of hydrogen ion and hydroxyl ion. This is equal to 10 to the power minus 14. Okay, this is Kw, ionic product of water. Okay, now in this case concentration of hydroxyl ion is given, so we can find out the concentration of hydrogen ion like this. Okay, this is divided by concentration of hydroxyl ion, and this will be equal to 10 to the power minus 10. Okay, this one, and its pH will be 10. How? Again use the same formula. pH is equal to minus log of hydrogen ion concentration and is equal to minus log of 10 to the power minus 10. Now again if you solve this pH, this minus 10 will come this side, so this minus and minus 10 plus 10, and log 10 is equal to 1, so pH is 10. At 25 degrees Celsius, pure water has hydrogen ion concentration 10 to the power minus 7 m. Hence the pH of pure water is 7. This is again you can find out using this formula. pH is equal to minus log of hydrogen ion concentration, and this is equal to minus log of 10 to the power minus 7, and that is equal to 7. So we can say in case of acidic solution where concentration of hydronium ion or hydrogen ion, same thing, okay, where concentration of hydronium ion is greater than 10 to the power minus 7 m, pH will be less than 7. Okay, in case of neutral solution, concentration of hydronium ion is equal to 10 to the power minus 7 m, so pH is equal to 7. In case of basic solution, concentration of hydrogen ion is smaller than 10 to the power minus 7, so pH will be greater than 7. Okay, again correlate concentration of hydrogen ion with pH. when concentration of hydrogen ion is lower, pH will be larger. Is it clear? And when concentration of hydrogen ion is greater, pH will be smaller. Okay. Now this is the ionic product of water. Kw is equal to, this is concentration of hydronium ion multiplied by concentration of hydroxyl ion, and this is equal to 10 to the power minus 14. Taking negative logarithm on both sides of equation. Okay, that's why we can write this is minus log Kw, this is equal to minus log of product of these two concentration. Okay, and if you solve it, you can write this is equal to minus, okay, this is in bracket, this is log of hydronium ion concentration, and this is plus, this is log of hydroxyl ion concentration. Okay, and now this bracket is closed. Now if you open this bracket, then we will get this one, minus log of hydronium ion concentration minus log of hydroxyl ion concentration, and if we take the negative logarithm of this, then we can write this is equal to minus log of 10 to the power minus 14. Okay, and now again this is negative logarithm of Kw, that is called pKw, like negative logarithm of hydronium ion concentration, that is equal to pH, and negative logarithm of hydroxyl ion concentration, this is equal to pOH, and negative logarithm of 10 to the power minus 14, that will be equal to 14. Remember this relationship. pKw is equal to pH plus pOH, and that is equal to 14. The pH scale is logarithmic. Okay, so a change in pH by just 1 unit also means change in hydrogen ion concentration by a factor of 10. Okay, if pH is changed by 1, that is hydrogen ion concentration is changing by 10. Similarly, when the hydrogen ion concentration changes by a factor of 100, the value of pH changes by 2 units. Measurement of pH. The pH of a solution can be found roughly with the help of pH paper and universal indicator. I think you are familiar with these type of papers. These are the pH papers. Okay, and this is the standard colored chart. When these pH papers are dipped in a particular solution, then color is appeared. That color is matched with this standard chart, so we can find out approximately pH. And this is a universal indicator. Same, if 1 or 2 drop of universal indicator is put or is kept in that solution for which we have to determine the pH, again color will be developed, and then that color is also matched with this chart. But this is rough. Generally we will get the approx value. For greater accuracy, pH meters are used. This one, this is pH meter. Nowadays, this is pH meter is available like this is pocket size. This is like pen. This is like pen. Simply this pH meter, simply dip this pH meter in the solution and you will get the result. Okay. Now this is the standard colored chart. This side strongly acidic. If we move from this to this becomes strongly alkaline. Just that is, if this red color strongly acidic, generally this is green color is neutral, and this is purple or violet color, this is strongly alkaline. Okay. Now see one question, problem 7.16. The concentration of hydrogen ion in a sample of soft drink is 3.8 into 10 to the power minus 3 m. What is its pH? So pH is equal to minus log of hydrogen ion concentration, and we have put this concentration of hydrogen ion is 3.8 into 10 to the power minus 3. Solve this log. So minus log of 3.8 plus log of 10 to the power minus 3. If we take the log of 3.8, we will get 0.58, and this will be equal to minus 3. Find out the solution of this. We will get 2.42. Therefore, the pH of the soft drink is 2.42, and it can be inferred that it is acidic. Problem 7.17. Calculate pH of a 1.0 into 10 to the power minus 8 2m solution of HCl. Now student, if we use this formula, that is pH is equal to minus log of hydrogen ion concentration, and if we put the same value whatever given in the solution, given in the problem, so you can write this is minus log of hydrogen ion concentration is equal to minus 8, and if we solve it we will get the result 8. Okay, is it correct? No. We are saying that this is a solution of HCl, hydrochloric acid, and hydrochloric acid is acidic, so its pH should be less than 7. But if we solve like this, we will get the pH 8. So this is not the correct way. Okay. Now this is a very dilute solution, and in such a dilute solution we can't ignore the hydrogen ions produced by the ionization of water. Okay. So in such a dilute solution, also consider the ionization of water, and if from water hydrogen ion concentration is X, and definitely when hydrogen ion concentration is X, that will also equal to the hydroxyl ion concentration. So total hydrogen ion concentration, this 10 to the power minus 8, this is from this solution of HCl, and this is X, this is from water. Okay, now find out X, value of X. As we know, Kw, ionic product of water, is product of the concentration of hydrogen ion and concentration of hydroxyl ion. Now hydrogen ion concentration is 10 to the power minus 8 plus X, and hydroxyl ion concentration is X, and that is equal to 10 to the power minus 14. And if we solve it, we will get this quadratic equation. X square plus 10 to the power minus 8x minus 10 to the power minus 14 is equal to 0. And if we solve this quadratic equation, we can find out the value of X, 9.5 into 10 to the power minus 8. Now what is this X? This X is the concentration of hydrogen ion from water, which is also equal to concentration of hydroxyl ion. So this is concentration of hydroxyl ion. So we can find out the pOH. Like pH, we can also find out the pOH is equal to minus log of hydroxyl ion concentration. So minus log of 9.5 into 10 to the power minus 8. And if we see the log table, this is log 9.5. If we solve this one, we can write this is minus in bracket log 9.5 plus log 10 to the power minus 8. And if we find out the value of this log 9.5 with the help of logarithm table, this will be equal to 0.9777. And if we solve this one, we will get minus 8. And if we round off it, then that will get 7.02. This is the pOH. Then what is pH? Sum of pH and pOH is equal to 14. So pH is equal to 14 minus 7.02 is equal to 6.98. This is slightly acidic. Okay. Now again, in this case, to solve this quadratic equation, this is a very difficult. So we can use the one alternate approximate method. If we assume that in such a dilute solution, concentration of hydrogen ion is also equal to 10 to the power minus 7m. Okay, like in pure water, we can assume that. Then we can say total hydrogen ion concentration 10 to the power minus 8. This is from HCl, and 10 to the power plus 10 to the power minus 7. This is from water. And now in this case, scientific notation addition. In the first chapter we have discussed. This is 10 to the power minus 8 is common. Then we'll get this is 1 plus 10, and if we solve it, this is 11 into 10 to the power minus 8. This is the total hydrogen ion concentration. Now again use the same formula. pH is equal to minus log of hydrogen ion concentration, and this is equal to minus log of 11 into 10 to the power minus 8. So we can write in bracket log 11 plus log 10 to the power minus 8. And if we see the value of log 11, this will come 1.0414. And if we solve this one, we will get this is minus 8. And final result is pH is equal to 6.96. This is again, we can say roughly equal to this one. This is also accepted. Okay, student. Thank you.